Hi, welcome to Lesson 4, Logarithmic Functions. In the previous three sections we've looked at exponential growth, exponential decay, and the base e as a product of exponential functions. And so from those three previous sections you've seen that x has gone from being in the base level as a multiplier, divider, adder, subtractor, or even being powered, to actually now doing the powering in the exponent. And so as we move through the rest of Chapter 8, one of the issues that we're going to face is how do we solve for x in the exponent. So let's look at some cases that we've had before. So if we look at x as a base, so we've had problems in the past like 2x equals 8. Okay, so that would be x as a base. So to solve x, for x there, we know that we have done things like divide by 2 and divide by 2, and so x equaled 4. X as an exponent looks like this. 2 to the x equals 8. And so that asks the question, 2 to what power is 8? And so x is no longer a base level sort of PEMDAS operation in terms of like multiplication, division, addition, subtraction, but now it's actually in the exponent we're solving. So we don't have any sort of operation to get x by itself at this point. And so we introduce logarithms. With 2 to the x equals 8, most people can do 2 to the x equals 8 in their heads and say, oh yeah, 2 times 2 times 2, so x is 3, which is great if the answer is a whole number. The problem we run into is what happens when it's 2 to the x equals 9. What happens then? So as we look at Lesson 4, we'll look at logarithms, their properties, and what does that mean for solving for x in the exponent.